Welcome back to the final session today for the Wi-Fi Forum. We're going to continue with presentation of case studies. And for this session, I'd like to introduce Mr. Wael Guibene, Platform Architect with Silicon Labs, and Mr. Gaetan Feige, Principal Engineer with Hechtman Venture Development. They're going to share some insight on how Wi-Fi is supporting new sets of IoT use cases. So thanks for joining, gentlemen. Handing it over to you.
Thank you, Sean.
Thank you.
So good morning, good afternoon, everyone, and thank you for joining us today. My name is Wael Guibene. I am a platform architect with Silicon Labs, and joining me is my colleague Gaetan, who is with Hechtman Venture Development. We both actually are serving different roles within the WBA as well. I co-lead the IoT working group, and Gaetan is a co-lead on one of our MDU working groups. So that without further ado, we'll get into the agenda for today. So we will be talking a little bit about the Wi-Fi IoT opportunity and how Wi-Fi is transforming the MDU and smart building applications. We'll talk about the Wi-Fi Halo, Wi-Fi sensing, and some resources at the end of the presentation today, and a bit of a call to action to join us and to work with us on some of the applications that we're working on. With that, I'm turning over to Gaetan.
Thank you, Wael. So good morning, everybody. So why is Wi-Fi transforming today the IoT opportunity? So the first important fact is that there are a huge number of Wi-Fi devices out there, more than 20+ billion Wi-Fi devices. And in terms of the IoT market today, we are considering that there are about more than 30% of IoT devices that are Wi-Fi enabled. Why 32%? Because there are, of course, many other technologies in Wi-Fi that are used for IoT, in particular Bluetooth, Z-Wave, Zigbee, but also on long-range capabilities like LoRaWAN, like NB-IoT, and others. So the Wi-Fi IoT chipset is going to be considerably increasing in the next years, going from 1.85 billion devices to 4.84 billion devices expected in 2030. So it's a huge increase. And at the same time as more and more devices are being Wi-Fi enabled, there is a considerable change also in Wi-Fi technology. New shipments for Wi-Fi 7 access points are expected. And the technology for Wi-Fi evolving is also improving in terms of capabilities like low consumption devices and so on, which is very important in the IoT market in the different areas we'll be looking into. So one of the biggest markets which is changing also for Wi-Fi is what's called the MDU infrastructures, the multi-dwelling units. Multi-dwelling units is basically a completely new paradigm in how to deploy Wi-Fi in buildings that are where multiple tenants reside, or community housings and other places. In most cases today, everyone has its own Wi-Fi and ISP, its own ISP subscription with its personal Wi-Fi. But it has coverage issues, it has interference issues, it doesn't provide you your own connectivity when you're in other areas of the building, like, for example, in common areas like gyms, in the elevators, in the basements, and so on. So there's a huge opportunity for Wi-Fi to go over this multi-dwelling unit market. And the market context for that is that property owners, property managers, are seeking a differentiation in operational efficiency. They're seeing when people come into for rent now in tenants, one of their main criteria is basically the quality of the network, the quality of the indoor coverage. At the same time, residents are expecting smart amenities, more and more connected devices, going into even those that we don't use that much today, like refrigerator ovens, and not talking about, of course, the common ones like the thermostats and others. So the energy savings that everyone is trying to drive is also driving this smart building adoption. Why is Wi-Fi, and we'll be talking about that, a key area for that? So first, the key use cases we're seeing are, of course, the common area connectivity areas. We talked about the elevators, the entrance building, the gym, but also the basement areas where sometimes there is no cellular coverage. And therefore, the Wi-Fi is serving as a replacement for deep indoor coverage. The smart metering for measuring, optimizing, and looking at if there are failures, if there's overconsumption, and all of these things. HVAC optimization, all leak detections for water, and so on. And all the amenity bookings and the occupancy management are key factors that property managers want to optimize. So as part of the Wireless Broadband Alliance, we have written a multi-dwelling unit Wi-Fi white paper, which will be published in this coming Q1 2026, not 2025. Sorry for the little mistake. So if we go on to the next slide, Wael, thanks. So the value for Wi-Fi and MDU applications. So the property owners are looking at using Wi-Fi to reduce their OPEX and have a premium positioning for all of the tenants that they will have. It's basically an ecosystem where deploying a managed Wi-Fi backbone in a multi-dwelling unit environment allows to connect IoT gateways, device endpoints, in a much seamless and easier way than today, because the Wi-Fi managed backbone is a complete and unified coverage across the entire building. There is not supposed to be any coverage areas that are painful, and so on and so on. For the residents, they're expecting the seamless smart home experience. And as we said, in all of the use cases that are being deployed today that we're working on, the residents are, as we're saying, asking for a strong network as a value proposition to get into a building, and asking also for more and more services. And for the ISPs, it's really a new revenue stream, because the ISPs today are trying to compete as well with over-the-top players to manage those IoT devices and so on. Wi-Fi is the convergence layer for all this fragmented IoT market today. And this convergence over Wi-Fi has been confirmed by a lot of the work that the CSA has been doing. So with the Matter standard, basically bringing Matter on a pure base Wi-Fi operations, including the thread protocol for basically connecting more and more devices. Next slide, thanks, Wael. So one of the key differentiations that's coming also in Wi-Fi technology that's a huge enabler for the use cases that we're working on and trials that are starting to happen is the Wi-Fi Halo technology. Basically, Halo is a sub-gigahertz operation, which allows to have much more range than today's world. Is someone ringing?
Very good.
Well, okay. I'm sorry for this. Everybody still hears me? Is it good?
Yeah, I think clear, yeah.
Okay, so the sub-gigahertz operation allows to have a long range for Wi-Fi Halo, basically competing with Z-Wave, LoRaWAN, and NB-IoT. And basically, this is something that is a game changer in the Wi-Fi world, because when people wanted to have a long range coverage for many sensors inside buildings, because a single access point wasn't sufficient, the Wi-Fi Halo is basically allowing this today, and bringing a local connectivity and local data management and local orchestration to all those IoT devices that are being connected over Wi-Fi Halo. So Wi-Fi Halo is really bringing the best of both worlds, the Wi-Fi ecosystem and the low power WAN reach that people needed to go for other technologies before. Next slide, Wael. So in terms of the Wi-Fi Halo adoption and the use cases that we're seeing and the studies that we're doing, the key verticals are various, goes from agricultural to industrial to smart cities and retail. Those multi-dwelling units also and property managers are looking at it. And this is really allowing the connectivity of IoT sensors across those buildings where today a single Wi-Fi or a standard Wi-Fi infrastructure was much more complex to deploy. Also possible to use video surveillance backhaul with some smart techniques for really motion sensing and so on, because Wi-Fi Halo, if it's too much dense, will not allow, of course, to stream as many cameras as if they were all wired. And from a silicon ecosystem perspective, the multiple chipsets are coming out. More and more vendors are joining the Halo ecosystem. There will be more competitive pricing, and that will drive the adoption. And of course, it's a standardized and interoperable technology. So it's available now, and field trials are actually happening now with all these new IoT sensing capabilities that people are asking for in Wi-Fi Hello. So I'm passing the ball to Wael for talking about another technology, Wi-Fi sensing, which is changing also the game of Wi-Fi.
Thanks, Gaetan, for the insights on the MDU space and on the Wi-Fi Halo. So another, I guess, like another technology that I'm really excited about here to talk about is the is Wi-Fi sensing. So what is it to start with? It's really kind of leveraging the existing Wi-Fi signals to detect motion, presence, and even gesture. No additional hardware required. You're just using the routers and access points already deployed with the devices that are within the network. And critically, it's really that privacy preserving aspect of it, because there are no cameras involved, yet we're able to detect people, count people, and even infer their gestures, and we look at some of the applications in the upcoming slides. So how does it work? It's the technology analyzes what we call the CSI, or the channel state information, which captures how the Wi-Fi signal propagates through obstacles and also reflect off of them. And when someone moves basically in an environment, the signal patterns change, and machine learning and application and artificial intelligence pattern recognition engines can interpret these changes and infer the motion in the between the devices and the access points, basically. There is also a standardization effort in 802.15.11 BF that's looking at more kind of progress to formalize these capabilities. It's really, I guess, like the fundamental, I guess, like insight here is that the Wi-Fi network becomes a sensor, and kind of the wireless capabilities are becoming a sensor, and the infrastructure kind of, you already have deployed can now detect and respond to a human presence. To look at some of the applications, specifically for like the commercial and the enterprise applications. So occupancy, for example, analytics for space optimization. That's where we understand how conferences, for example, conference rooms and workspaces are actually used. For example, in elderly care facilities, it's the elderly care and the fall detection, really, kind of, which is a major application in assisted living facilities. When we talk also about security monitoring, without the privacy concern of cameras, and also ultimately the energy management through understanding how these spaces are being used in order to drive things like HVAC in a building altogether. So for commercial and retail environment, I guess like it's customer flow that helps retailers understand how people are basically moving through the stores, and also the gesture-based interaction that enable touchless interfaces basically through Wi-Fi sensing. The WBA has a long history, I guess, like investigating Wi-Fi sensing altogether, and there is a technical paper back in 2024, and I think there was also an updated version of it on the resources, which details the technical specification and the implementation guidelines when it comes to Wi-Fi sensing. It's I guess like the only other point I would want kind of not to hammer on is the privacy advantages here. Cannot be overstated, as you get the behavior insights of camera-based solution without a privacy implication. So no video, no images, just presence and motion data through the wireless interface. And on the residential applications, Wi-Fi sensing enables three major categories, like home security, for example, where motion detection without cameras, again, that privacy preserving monitoring and intrusion alerts. This is particularly appealing for customers who want security but are uncomfortable with camera setups inside their homes. There is also that sleep monitoring. We're seeing that more and more with like non-contact sleep tracking, movement pattern analysis, and health insights, all without wearing devices or installing cameras in a bedroom, all done through the Wi-Fi motion sensing. There is also the smart home automation, where it's the presence-based lighting system, for example, that responds when you enter a room directly. There's also the HVAC optimization based on actual occupancy, devices, triggers, automation as well. And the point here is always that privacy first, no images, no video, just the Wi-Fi that you deployed in your own home can unlock these new applications. Finish it, I guess, like to finish off, really, kind of, the WBA has put resources, and some of them are the technical white papers, like the Wi-Fi sensing that we mentioned, Wi-Fi Halo, smart home, and IoT interoperability, that I would encourage everyone to look at. There is one, again, sorry for the small typo there, it's not Q1 2025, it's 2026. It's our MDU, I guess, like beyond Wi-Fi, it's really kind of the MDU, the IoT aspect of MDU that's coming soon. And there's also active groups that I would encourage everyone to get familiar with and to get involved with, like the IoT working group. That there is also the MDU working group that's also coming as a second phase to our first work that was delivered last year. I guess that's really it for this section. Back to you, Sean.
All right, gentlemen, I think that was a great final presentation that really highlights the broad value Wi-Fi is delivering today and will continue to deliver. So I appreciate you taking the time to share your perspective and the work you're doing with the forum. And for everybody in the audience, if you'll join us back here in about 90 seconds, my colleague Catherine is going to wrap up the day for us. So thank you, everyone.
Thank you.
Thank you, everybody. Have a good day.